The new ultra-deep image from the JWST suggests that we may have made a serious error. The James Webb Space Telescope, JWST, has been nothing short of revolutionary since its launch in 2021. Its unprecedented clarity, ability to peer into the farthest reaches of space, and its capacity to look back in time to the formation of the first galaxies have made it a game-changing instrument for cosmology. One of its most significant revelations came with the release of the ultra-deep field image, which sparked both excitement and controversy in the scientific community. As astonishing as the image is, it raises profound questions about our understanding of the universe. In fact, some scientists believe that the new ultra-deep image from JWST suggests we may have made a serious error in our assumptions about the cosmos. The JWST ultra-deep image, a glimpse into the past. The new ultra-deep field image produced by JWST offers an unprecedented view of the distant universe. The image captures galaxies as they appeared more than 13 billion years ago, shortly after the Big Bang. The depth and clarity of the image far surpass that of the Hubble Space Telescope's iconic ultra-deep field, revealing a greater number of galaxies, some of which appear to have formed far earlier than previously thought. This stunning view of the cosmos presents a timeline that goes further back in history than ever before, showing stars and galaxies at an age when the universe was just a few 100 million years old. For decades, cosmologists have operated under the assumption that the universe began with the Big Bang approximately 13.8 billion years ago. After this initial explosion, the universe expanded and cooled, eventually leading to the formation of the first stars and galaxies in what is known as the cosmic dawn. However, the new image from JWST seems to call this timeline into question. A crisis in cosmology? The JWST's deep dive into the universe has shown something unexpected: galaxies that appear far more developed than we would expect at such an early stage in the universe's history. Some of these galaxies are massive, well-structured, and seem to have already gone through stages of star formation and evolution that shouldn't have been possible in the short time after the Big Bang. This finding has raised concerns that the models we have relied on for decades may need significant revision. One of the key issues with the new data is that it challenges the widely accepted lambda-cold dark matter, lambda-CDM model of cosmology. The lambda-CDM model is the cornerstone of modern cosmology, describing a universe that is primarily composed of dark matter and dark energy, with only a small percentage of its mass made up of normal matter, the stuff we can see. The model has successfully predicted many of the universe's large-scale structures and helped explain phenomena such as the cosmic microwave background radiation, CMB. However, the newly discovered galaxies, with their surprisingly advanced structures, seem inconsistent with what the lambda-CDM model predicts for the early universe. Galaxies that shouldn't exist? One of the most puzzling aspects of the new image is the presence of fully formed galaxies that appear to be only a few 100 million years old. According to the standard cosmological timeline, galaxies at this stage of the universe's evolution should be small, irregular collections of stars, just beginning to come together. Instead, JWST has captured massive, disc-shaped galaxies that are far too mature for their age. These findings have led some scientists to propose that we may have misunderstood the rate at which galaxies form and evolve. If galaxies can form and mature much faster than we previously thought, it could imply that some key aspect of our understanding of galaxy formation is incorrect. Alternatively, the existence of these galaxies could suggest that the universe itself is older than we currently estimate. This would fundamentally challenge the Big Bang model, as it would imply that the universe had more time to form complex structures in its early stages. The discovery has left cosmologists grappling with the possibility that our estimates of the age of the universe could be off by a significant margin. Dark matter and dark energy, rethinking the basics. The JWST image also has implications for our understanding of dark matter and dark energy, the mysterious substances that make up the vast majority of the universe's mass and energy. Dark matter is thought to be the scaffolding that allows galaxies to form and cluster together. However, the early appearance of massive galaxies in the JWST image suggests that dark matter may not behave as we have theorized. If dark matter were as cold and slow-moving as the lambda-CDM model predicts, the formation of these large, well-structured galaxies should have taken much longer. This discrepancy has led some researchers to suggest that we may need to revise our theories about the nature of dark matter. Perhaps dark matter is more dynamic or interacts with normal matter in ways we haven't yet observed. Similarly, dark energy, which is believed to be driving the accelerated expansion of the universe, could also be more complex than we currently understand. If the JWST data shows that galaxies formed earlier than expected, it could indicate that dark energy behaved differently in the early universe, affecting the rate of expansion in unforeseen ways. Time to revise the Big Bang model? For decades, the Big Bang model has been the dominant theory explaining the origin and evolution of the universe. The model is supported by a wealth of observational evidence, from the CMB to the expansion of the universe itself. However, the new ultra-deep image from JWST has brought certain aspects of the Big Bang theory into question. If the universe's first galaxies formed much faster and earlier than we thought, it suggests that some critical component of our cosmological models is missing. Some cosmologists have even begun to speculate that the Big Bang, as we currently understand it, may not be the true beginning of the universe. Instead, they propose that the universe could have existed in some form before the Big Bang, with the event we call the Big Bang being a transitional phase rather than a true origin point. This idea isn't entirely new. Some cosmological theories, such as the cyclic model, propose that the universe goes through periods of expansion and contraction, with each Big Bang marking the beginning of a new cycle. The JWST's findings lend some support to this line of thinking, suggesting that the universe's history may be more complicated than a single, one-time explosion followed by continuous expansion, challenges, and future directions. While the new JWST data presents some serious challenges to our understanding of the universe, it's important to remember that this is just the beginning. The telescope has only been operational for a short time, and its findings, while groundbreaking, need to be corroborated with further observations and analysis. Scientists are already planning follow-up studies to better understand the implications of the ultra-deep image and to determine whether these early, mature galaxies are truly as old and massive as they appear. One possibility is that the galaxies in the JWST image are not as distant as they seem, and that some unforeseen factor is distorting our measurements of their distance and age. Another option is that our models of star formation and galaxy evolution are incomplete, and we may need to refine our understanding of how galaxies grow in the early universe. Moreover, theoretical physicists are already working on new models that might explain the JWST's surprising discoveries. These models could lead to a deeper understanding of the fundamental forces that shape the cosmos, or they could introduce entirely new concepts that challenge our current understanding of the universe's structure and evolution. Conclusion: the new ultra-deep image from the James Webb Space Telescope has sent shockwaves through the scientific community. Its stunning revelations about the early universe suggest that we may have made a serious error in our understanding of cosmology. Whether it's a matter of revising our theories about galaxy formation, rethinking the role of dark matter and dark energy, or even reconsidering the Big Bang model itself, the JWST's findings mark the beginning of a new chapter in our quest to understand the universe. While the challenges posed by the JWST image are daunting, they also represent an exciting opportunity for discovery. As we continue to explore the cosmos with JWST and other next-generation instruments, we may uncover even more surprises that push the boundaries of our knowledge and help us unravel the deepest mysteries of the universe.